Okay, now we're going to go ahead and take a look at graphing logarithmic functions. Now, we have just the log of x. But remember that log of x is really a common log of log base 10. So there's really a base here of 10, even though it's not written. So I want to go ahead and first of all choose some numbers that I can maybe do off the top of my head. And that's the numbers here, 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 and here. So if you would plug in a 10, you'd have log base 10 of 10. You can either remember that when the base and this here are the same, they undo each other, so it would leave you with 1. Or you could think of it as your base of 10, 10 to some power equaling what this is, which is 10. So 10 to what power is 10, and that's 1. Here you can think, okay, 10 to what power is 1? Well, 10 to what power is 1? And that's 0. Here, this is 1/10, so you got to think, okay, 10 to what power is 1/10? Well, that's 1 over 10, so that's a negative 1. Here, this is 10 to what power is 1/100th? Well, that'd be a 1 over a 10 squared, or a negative 2. This one here would be 10 to what power is 2? Well, that one is not easy to figure out off the top of your head. So for the 2, the 3, and the 7, I would just go ahead and plug that into my calculator. Now, considering that we're graphing these, it's not much, or it's not real easy to get more than the accuracy of 1/10 when you're looking at a graph. So going to 1 or 2 decimal points is probably all the farther you have to go here. Now, all we have to do is plot our points. Here we go 10 over, 1 up. Here we go 7 over and 85/100ths up. 3 over, almost up a half. And well, when you do that, you end up getting a graph that looks like this. Now keep in mind, all logarithmic graphs have a vertical asymptote. And so as we get closer and closer to the y-axis here, which is really what causes, you got to just think, this thing that's after the log, what would cause that to be 0? In this case, that's 0. So x equaling 0 is going to be your vertical asymptote. So there's a vertical asymptote here that goes down forever. So you got to think, okay, if I have a plus 2 afterwards, what's that going to do to my graph? Well, remember in graphing, you should realize that that's going to move everything up 2. So that's going to take our graph that we had here and move everything 2 units straight up. When I do that, that ends up giving me this graph right here. When I look at this one here, you got to think, oh, that plus 5 is hanging out with the x, so that's going to move it left and right. Since it's a plus 5, it's going to move it to the left, kind of the opposite of what you would initially think. Also, keep in mind that whatever is after your log, what causes that to be 0, that's where your vertical asymptote is. Well, what would cause this to be 0? Negative 5, so you'd have a vertical asymptote at negative 5. So it's really basically taking this blue graph right here and moving everything 5 units to the left. When we do that, we get this green graph. Once again, we have our vertical asymptote going down forever.